In this lesson, we are going to learn how to find the measures of spread of a dataset. They are also known as measures of variation or measures of dispersion. And in a previous lesson, we learned how to find the measures of central tendency, the mean, median, and mode. I want to show you two sets of data. Let's take the first data set to have the following numbers, 7, 8, and 9. And then the second data set to have 2, 8, and 14. Very small data sets. Now, for the first data set, the mean, if we calculate the mean like we did in that lesson, the mean is the average. So if we add 7 plus 8 plus 9, that's 24, divided by 3, because there are 3 numbers here, it's 8. So the mean of the first data set is 8. And then the median, which is the middle number, is of course 8. And we do not have a mode because no number is repeating more than other numbers. In the second data set, the mean will be the sum of these 3 numbers divided by 3. So it's going to be 2 plus 8 plus 14, which is 24, divided by 3. So the mean is also 8. And the median is, the middle number is also 8. And we do not have a mode. So if we focus on the measures of central tendency, notice that two very different data sets have the same mean. Both of them have a mean of 8 and the same median. However, the data sets are very different. In the first case, the numbers are very close to the center. 7 and 9 are very close to 8. They are only 1 unit apart, each of them, right? In the second data set, they are not as close to the center. So 2 is 6 units from 8. 14 is 6 units from 8. So this second data set is more spread out from the center. So focusing on the measures of central tendency is not enough. That's why there is the need for finding the measures of spread in statistics. And our objective for today is to find and describe how data is spread out using the following measures of spread. We're going to focus on range, and then on the interquartile range, also known as IQR, variance, and standard deviation. So these are the 4 measures of spread. Let's start first with the range. The range is the difference between the highest and lowest values in a data set. So this is the formula that we are going to use to calculate the range, is the maximum minus the minimum. Very easy measure to find. Let's look at a couple of examples. So here we have a data set. To find the range, we are going to find the maximum value. The numbers are not in order. So you either want to reorder the numbers from least to greatest, or just quickly look at the data set and find the biggest number. So the biggest number is 9, and that's the maximum. And then the smallest number is 2, that is the minimum. So the range will be the maximum value minus the minimum value. So it's 9 minus 2, which is equal to 7. Again, make sure that you order the numbers from least to greatest if they are not in order, or just look carefully upon the data to identify the minimum and the maximum value. All right, let's look at another example. This is a larger data set. Let's find the maximum value. The biggest number of all of these is 30. So this is our maximum. And then the minimum is, if you look at all these numbers, the minimum is 12. So the range will be 30 minus 12, which is 18. Now let's focus on finding another measure of dispersion, which is the interquartile range, also known as the IQR, which by definition is the range or the difference between the first quartile, Q1, and the third quartile, Q3. Let's find the IQR for this example. We have this data set. It's already in order from least to greatest. And we have a total of 10 numbers in this set of data. The first 5 numbers make up the lower half of the data, and the other 5 numbers make up the upper half. Q1 is the median of the lower half. So if you look at the lower half, the number that's in the middle for these 5 elements is 14. So this is our Q1, lower quartile or first quartile. And then if you look at the second half of the data, the median of that half, number that's in the middle, that's our Q3 or upper quartile. Now, the interquartile range by definition is Q3 minus Q1. So it's going to be equal to 24 minus 14, which is 10. Now let's look at the variance and the standard deviation. These are two very important measures of spread or variation. And let's start with the variance. By definition, the variance measures the average squared deviation from the mean. And we're going to use this symbol, sigma square, for the variance. And if you look at this formula, it looks very complicated, but really it is not. What this symbol means is that we're going to add, this is the sum symbol in mathematics. So we're going to add some numbers, and the numbers that we're going to add are squares of differences between each number in the data set. So xi represents each number in the data set, and mu represents the mean of that set of data. And then we're going to divide this sum of squares by the number of elements in that population, right? So by the number of elements in the data set. And what we obtain is called the variance. The standard deviation is simply the square root of the variance. So we're going to say sigma, the standard deviation, is the positive square root of the variance. So that's what's going to take longer to calculate, the variance. Once we find the variance, we simply take the positive square root of the variance, and that will give us the standard deviation. Let's look at this example together. We have a very small data set here, only 3 numbers, 2, 4, and 6. And we want to find the variance and the standard deviation. But we're going to have to start by calculating the mean. So the mean is, of course, 2 plus 4 plus 6 divided by 3, which is 12 divided by 3, which is 4. Now, to find the variance, or sigma square, we need to find the difference between each of these numbers and the mean. And we're going to square each of those differences. And we're going to add up those squares. So we're going to have 2 minus 4. That's the first difference. And we're going to square this difference. Then we're going to have 4 minus 4 squared. And then finally, 6 minus 4 squared. So that's the sum of the squares of those differences between each number and the mean. And then we're going to divide that sum by the number of elements in this data set. There are 3 numbers in this set of data, so the denominator is 3. All right, so we have 2 minus 4, which is negative 2 to the second power, which is 4, plus 0 squared, which is 0, plus 2 squared, which is 4, divided by 3, which is 8 over 3. So the variance, if you change that to a decimal, is 2.67. To find the standard deviation, we are going to take the square root of the variance. So the square root of 2.67, and that's going to be approximately equal to 1.63. Let's look at one final example. We want to find the variance and the standard deviation for this data set. So we're going to start by finding the mean. So the mean or the average will be 4 plus 7 plus 10 plus 6 plus 8, which is 35, divided by the number of elements. So there are 5 numbers in this data set, so we're going to divide that by 5. So the mean for this data set is 7. Now, to find the standard deviation, we need to find the squared deviations, or the squared differences between each of these numbers and the mean. So we're going to start with the first number. We have 4 minus 7, and then we're going to square that difference, plus 7 minus 7 squared, plus 10 minus 7 squared, plus 6 minus 7 to the second power, plus 8 minus 7 squared. And we're going to divide everything by 5 because there are 5 numbers. N is equal to 5. All right, so let's go ahead and perform those computations. 4 minus 7 is negative 3. Negative 3 to the second power is 9. This is 0. 0 squared is 0. 10 minus 7 is 3. 3 to the second power is 9. This is negative 1 to the second power, which becomes positive 1. And then this is 1 to the second power, which is 1, divided by 5. So we're going to have 9 plus 0 plus 9 plus 1 plus 1, which is 20, divided by 5. So the variance is 4. Sigma squared, that's the variance, is equal to 4. So now to find the standard deviation, we simply need to take the square root of the variance. So square root of 4, the positive square root of this number is 2. And that is our standard deviation.